Okay, today we're going to be talking about 11.4, the properties of logarithmic functions. And I just have the shortened version of log here. Kind of a play on words. I showed you some different logs here in our picture. But really what we're looking is the mathematical representation of logs, which is shown here as they have the graph here of log base 2 of x is the graph. So we're going to get into the mathematical value of log. So hopefully by the end, today we're going to have two videos. The first one's going to be in evaluating expressions that involve logs, and then we're going to get into how do we solve equations that have logarithms as well. So let's just start off with, okay, some different things. What's 10 to what value equals 100? And hopefully in your head you're saying, well, Mrs. Kennedy, 10 to the second equals 100. Therefore, in this equation, x would equal 2. I'd be like, great. And then you'd say, well, same theory, 10 to the third equals 1,000. Therefore, in this equation, x would equal 3. 10 to the fourth equals 10,000. So in this equation, x would equal 4. It'd be very good. Now, when your base is 2, it's not as easy or maybe as natural, or you might not have covered stuff like this in science like you have with the base 10, to come up with what the answer is, but maybe you can still come up. Maybe you can do some guess and check. So you might start on a calculator and say, well, what is 2 to the third? I know is 8, so what's 2 to the fourth? Maybe that's 32. Nope. 2 to the fourth is 16. 2 to the fifth, oh, that's 32. And so you kind of would work it through that way and say, okay, what I know is I know that 2 to the, excuse me, I said third, 2 to the fifth here, sorry, is 32. Therefore, in this equation, x is a 5. Here, I know that 2 to the 6th is 64. Therefore, in this equation, x is 6. I know 2 to the 7th is 128, and therefore, in this equation, x equals 28. Well, that's kind of what we're getting to. We're saying, what if you have a problem like 6 to what value equals 216? What do you do when you don't know for sure 6 to what power? You could always do guess and check. So you could always go back and do guess and check. But then there's sometimes where it might not be to 3. It might be to 1.5 or 3.5 or 3/4 or something like that. So what we are going to do, or what we use to solve it, is a value called logarithms. All right, a logarithmic function is corresponds to an equivalent exponential equation. And really what it is, it's the inverse of an exponential equation. So a log function is when we take the inverse of an exponential equation, we get a log function. So if you remember, here's my exponential equation. Y equals a to the x value. Okay? And actually usually it's ab to the x value. It's usually what we say, because there's, you'll see kind of later when we talk about this again. We say that's our exponential equation. Inverse is, if you remember, switches your x and y, and then usually we then resolve it again for y. So in order to resolve it again for y, that's kind of how they came up with, oh, to resolve it again for y, they actually came up with this, that it's going to be log of, let's call it b down here, e of x equals the y value. And we'll kind of get through this a little bit more. But I kind of wanted to say, just kind of the point I'm trying to make is exponential, or that logarithm is inverse of exponents. What I need you to know is that when we do write an exponential equation, we have a base, and then we have an exponent, and it equals a value. To go from exponential form to logarithmic form, there's still a base. So we're going to have log of a base of a number, but it's going to be log of the base of a number of the value equals the exponent. So what happens, like in this problem, we have y, or 2 to the y power equals 32. The way I always thought of it, I'm going to show you this a little bit better. That kind of looks a little sloppy. 2 to the y equals 32. And all we're trying to do is say, and how can we show this in a log base instead of in a log function, instead of an exponential function? The way I was taught is that you switch around your exponent and your value, and then you add the word log. So now it's log base 2 of 32 equals y there. So what we're doing is we're switching around the two values, kind of just to know, remind yourself the kind of the process. We switch around the two values that are on either side of our equal sign. And then we always have a base. So whether it's the base of an exponent or the base of the log, your base is the base is the base. So the base doesn't change. We always keep the base a base. And what changes is kind of either whether you're taking the log of something or whether it becomes an exponent or it's what it's set equal to. So let me show you an example. So this first one example says write each equation in exponential form. We have it in logarithmic form. So in my head, what I'm doing is I'm saying to myself, how can we switch these two things around? So in other words, I'm going to switch the 1/3 and the 3, and I leave the 27 where it is and I drop the log to make it an exponent. So now it really becomes 27 to the power of 1/3 equals 3. Now I need to make a note here that what we're doing here is rearranging. All right, so here I'm just kind of checking, do you know how to go from one form, logarithmic, to exponential and exponential logarithmic? We are not, however, solving. Every semester I teach this, I get students who kind of get stuck on this and they think that they should be solving, and they're like, okay, wait a minute, now how do I solve it? How do I solve? There isn't a solving. This is just a simple question that's saying, please rearrange it. Show it to me in a different way. And so I kind of want to make that point, that it's really just showing it in a different way. So here, I'm going to show this 4 and the 1/2, and that's the two that I'm going to switch around. So it would be 16 to the 1/2 equals 4. So you can kind of see how I switched around the two values that are around my equal sign. Here in A, I'm going to switch around the 10 and the 124, your exponent and your value. So I'm going to add the word log, so it's in exponential form, of base 2. Now I'm going to say of 1024, and that now equals 10. So if you see, I switched around the 10 and the 124, and I have that log is now my base. So I'm going to say log base 2 of this time 1/8. So we see this as its own little value there, that 1/8. Same thing with the -3. We see it as its own complete value. So that equals here -3. Okay? So now we're going to get into what happens when you have log base 4 of 64. Now this is actually saying this, the directions would be actually please solve. And actually it's going, yeah, it's going to be solve, or it's going to be find the value. Okay, evaluate. Find the value of. Okay? So with this one, how I think of this is I say to myself, it equals x. Log base 4 of 64 equals x. And so I first put it into exponential form. So putting it into exponential form, we found out then that 4 would be raised to the x power, and that would equal 64. And this is a lot like those problems I started with. You're going to say to yourself, 4 to what power equals 64? And so I'm looking for the power. And here's where guess and check was really going to be beneficial to you. So I might start and say, well, I don't think it's 4 to the second because I know that's 16. But what about 4 to the third? What is 4 to the third here? So 4 to the third is 64. And I could come back and say, well, since 4 to the third is 64, my x value was a 3 that I was dealing with here. Beautiful, works out just fine. Another example here, set it equal to x. I'm going to say here, now 4 to the x equals 8. This doesn't go as quickly as the one before it because 4 to the second is not 8, 4 to the second is 16. So I'm going to take a little bit more work. One of the tricks I have, and I want you to follow, is that it's easy to find it if they have the same base. So in other words, I'm going to rewrite this 4 as a number to a power. And the one that I know the best is 2 squared. So I rewrote the 4 as 2 squared. Same thing with the 8. How can I rewrite the 8? I'm going to rewrite the 8 as 2 to the third. Well, then I'm going to kind of go back up here. 2 squared to the x is really 2 to the 2x equals 2 to the third. 2 raised to the power of 2x is the exact same value as 2 raised to the power of 3. What that tells me then is that the 2x has to equal the 3. If the bases match, then the exponents must be equal. Well, if 2x equals 3, I can divide both sides by 2, and x must equal 3 halves, or you can say 1 1/2, 1.5. Okay? Let's do the same sort of problem here with this next problem. Log base 125, or excuse me, log base 25 equals 125. So I'm going to set it equal to x. I'm going to say 25 to the x power equals 125. My next step is, how do I put them both with the same base? I think the most common base I would use here is a 5. This is 5 squared, and I'm just going to make it 5 to the 2x, because it was 5 squared and then taken to the x power. And so I just kind of realizing now that's 2x. 125 is 5 to the 3rd power. So now, again, my bases match, which means my exponents must be equal. 2x must equal 3. Therefore, my x must equal, again, it just happens to be 3 halves, or 1.5. One final example here. So log base 8 of 16 equals x. So I'm going to say to myself, 8 to the x power equals 16. And again, you're going to want to say 2, but it's not 2. 8 squared is 64, not 16. 8 times 2 is 16, but that's a little different scenario there. So now our next best case is to say, how can I put my 8 into have something raised to a power, and my 16 have be something raised to a power? The quickest one I can think of is 2 cubed is 8. So I'm going to make that 2 times 3 to the x, and that's the same thing as 8 to the x. And it just so happens 2 to the 4th is 16. Again, once you have matching bases, in other words, the bases are identical, you can say the exponents therefore must be the same. 3x must equal 4. If 3x equals 4, then our x equals 4/3. And go ahead and just leave these in fractions. I think that's our best way. So at this point, I'd want you to complete, and I think it's good just to complete the front side of the worksheet, and it says 11.4 worksheet on the front, and just kind of do the front side of the worksheet. I've done a couple of them for you here. So you have 1 through 8, and then I also want you to do, oops, sorry, I have another part of this worksheet, 9 through 14 as well. It might even be more than that. So I want you to do the front side of the 11.4 worksheet, and we're going to have another video that talks about how do we complete that back side of our worksheet.